Welcome back to Wickerson Studios. Michael Wickerson here. Just give it a second to load up. Just check my sound. Testing, testing. Problem. A little better now. Okay. Little summary here of advanced Numpy. At least the first of the two scripts that I'm packing into. I have this one to start. It's pretty compact. It has only one data visualization within it. And then I also have the beginnings of broadcasting, which I'm doing fairly well. And I should finish the series of Advanced NumPy off with this afterwards. But right now, we're just going to do a little summary of the first one, which adds another 1,000 or so lines of script to our already 4,120 lines of script. So NumPy, I've brought it in here. And what I did was right off the bat, I just ran through using GitHub Copilot what it wanted to teach me. And the first thing it wanted to teach me about was strides. And strides are a way to tally the stride of a multidimensional array. So we're going to start with setting up an array with a huge range. And then we're going to run that in a very simple script and calculate the strides. Now, if it's not working when you jump in here, which it probably won't be, run it. And see if this activates it. If it doesn't, this is usually the case that this sometimes needs to be totally unplugged, and sometimes it has to be completely run again, and then you have to plug into it. And this is another form that can work. So you don't have to go to what I said before, which is bringing down one of these, going up here and grabbing the call name and number. And then you have to go in here and pop it in there. And then if you do that, then you got to hook everything up again, which is a pain. So that was a nice shortcut that I only found out now. And you also won't have to go in here and take off the cache memory and server because you're making a new node. So that's a very nice, convenient thing. So basically, you're calculating the stride of how big this needs to be in spaces and bytes to store on your computer. So there are your multidimensional arrays. We make it as small as we want, a little 1 by 1 by 1 deep. That's a pretty boring little number. There it is. But then you can take it back up to where it was. I think 3, 5, and 4 is a pretty substantial size multidimensional array to drive data trees. The very next item is type, which produces Boolean. So let's do the same thing. Maybe we can just go back in here into the path and hit run. That might do it, but then we might have to rehook it up. There we go. So just rerun it like that. And this is saving me a lot of time. So for those watching this, can't believe I didn't figure this out before. Like I said, all my cached memory should be off, but this one wasn't. So as we take that, as we change that count, it might have an effect of it. But since we're just comparing types, we're trying to find out if is this type part of that type. So is integers part of floats, floats are part of integers, and that's using the function here. Nice and easy. The NP MRO method is pretty cool. So the MRO method is one that's going to go in and it's going to tally up. And I decided to put this to strings to make this one work. So let's go to paths and hit on and take off the cache memory. And we should be good to see this one run. And there it is. It's telling us the class float, the class, it's giving us all this information about each one as to how it fits. Now, MRO, I'd have to go back in. The MRO method returns a tuple of types of that class is derived from an order from base to, let's just say from base. Let's just add this to the subclass. So if that's something you're going to end up using, then go ahead. But otherwise, we're getting into advanced array multiplication, and we're going to jump in and do what's really interesting, and I think it gets it up and running. So click on here, run it again, and it should be good to go. And if you do a little slide factor, you should be able to grab your data. Now, what is going on here? I've got a reshape array, which is right here, and it wants to basically, didn't hard code anything in. It's basically reshaping the array, but can it reshape it? What is the problem here? Parameter the first data. What happened to my list? What happened to my list? That's very interesting. Let me copy this and give it a list of numbers. I don't know why I've lost that. Maybe I took it off somehow. That list is not working, and it will work when it is set to 8. I see why the list, the series count has to be for this one to work. And this is where I become a little parametric here. I'm just going to use a little math so I don't have to bother with all this. I'm glad I caught this. If I'm going to do a 4x2, 4 rows by 2 columns, then I'm going to want that as my count. And then that will function and be a little more parametric to how that sets up. So you've got your list in, and that should be able to tally that. And there we go. Reshaping an n-dimensional array. So that's it. You can rechange that and it works. And then hopefully this has been taken off the cache, which it hasn't. And we can go down here and see how that updates as we slide through here. And there we go. Generating your arrays. Reshaping an n-dimensional array. Now this one's work. And I guess this is where I started to bring in a little bit of scripts. And as we slide down, this will be reshaping 3, which I have to get up and running right here. Reshaping 3 is that one. What was the one before it? Reshaping 2, did I actually have it? Yeah, so reshaping 3, I'm going to go in and I'm just showing how, oh, the first one was how it wasn't set up. And then I fixed it, so I actually made this one into this one. So not a big deal. Let's just click on this paths and set it and roll it through so it'll run, and it'll have to be 20 for it to run because that 20 divided by 4 will set the columns up. So that's your number. And I think this is something that obviously if I want to get the array set to fit the data, I think it has to be divisible by 4. So this will work for 20, it'll work for 16, it'll work for 12. Otherwise, you're not going to get these boxed arrays. You're not going to get the arrays working out to how it is. And then I'm outputting, if you take a look down here, I'm starting to use really nice array to list, and then calling those elements in each one to solve that. And so what did I do on the next one? The array, this is 4. What did I do differently on this one? We'll do 3. 4 here is the same example of rows and reshaping it. And I wanted to reshape it from rows. So what was the difference? It's reshaped, okay. And then this one I've used the npy range to reshape it. So it's just a different way of doing it. So jump into here, take your cache server off. I should have watched that. I'm going to save this file so it's a little more up to date and I've fixed my errors. It's always good to do a dry run of this before I'm going to issue this. This is going to be the seventh, so the first of 2 for NumPy advanced arrays, and I'm going to add that to the kit at Wickerson Studios, the full package. Also the full package, but also the full bundle of NumPy scripts today. And if you've already purchased or anybody has already bought the first set, then just call me and I'll put you on your GitHub name onto the repository. And so let's go to path and let's hit run and let's just do a little slider factor. It'll buzz out and there we go. Get that running pretty good, that we can actually once again reshape our array. And what we did differently here was that NumPy A range to solve it. So then what we got into, the opposite operation of reshape, is a one-dimensional or higher from one-dimensional or higher dimensions is typically known as flattening, and we don't really want to flatten. So I think the other word for it is raveling, and I think that's cool because I've always been using flattening the grasshoppers. So why not change our names and let's deal with this one? And so we may type in flatten, but I don't think we're going to. We're going to use ravel in both cases here. Note we did do ravel and flatten, and you'll see the difference. So as we jump in here and see a ravel script, it's down here. It's not too hard. It's the array raveled. We run it, and then we have our rows and columns, and as we put it in, you'll see it flattens to data that we might want. And then the same thing here, double click on here. Boy, this is speeding things up doing it this way. We can flatten that list this way and that way, and we have that powerful use of the flatten, which is familiar to most people. And then there's a little bit in here of what is the difference between multi-dimensional data and how it's stored in one-dimensional blocks of memory. And then you can actually store it in two different orders, the Fortran order and the C order. So I actually threw that in here a little bit. And here's an example of both, how you would read one and how you would read the other. So let's jump in here and hit OK. And then let's slide that parameter back to 12. And there you go. You see the order of, actually I think I flattened. That's the original list of what's in there. And then you can see the flattening too. If I'm correct, I think I bring it out into the Fortran order. And there's the Fortran order of how you see it different. So instead of 1, 2, 3, 4, 5, how does that work differently? Again, take a look up here. You'd have to take a look through actually running it and see it in the terminal window between C, because I didn't choose that. I just chose to show the reshape in the Fortran order, and that's what you end up getting. So that's pretty exciting. I think I used 12 because 12 is this. So I probably should have divided it by 12 by 4 to get the rows. And that's one way to hard code this. So you do a little bit of do-si-doing here. If we take 12 and we divide it by 4, then we have our 3 for columns, and that should work. And then when we update it, as long as it's divisible by 4, I think it should run as a script. Yeah, 20, 16, yeah, the same thing. So you're just thinking of your array. You have to think multi-dimensionally. That's it. I'm going to go down to 8. There we go. Then we get those numbers. But I think probably a higher digit here will allow us to see the other one. So that's a little bit about the closest I'll ever get to see in Fortran, and I'll never go back to it. I was going to do some data visualization with that to show how it changes from the list, and I never got around to it. The next thing that's in here is concatenating. So that can be very cool because that'll avoid anything that you might waste your time over here in text trying to figure things out over here in Grasshopper. But concatenating series, here's a nice example. Let's run it. Okay, let's slide it through 9 and 9. And now what we can do is take all these series and then we can concatenate them together. But as we concatenate those different series, which are literally a count of 3 each, you see, well, you won't see it over here because I've got so many other scripts, but it'll actually pull those scripts together, which is kind of nice. So it's going to grab 1, 2, 3, the steps 1, 2, 3, then 4, 5, 6, 7, 8, 9, and 10, 11, 12. Okay, so concatenation right there, and we're doing it in the 0 axis. So that's the first one. Nope, that's the second one. The second one we've done here is we've done it in the first axis. So that's nice. How did I miss the first one? That's by the 0 axis. Hang on a second. 0, concatenating. There it is. Concatenating by 2 lists. Okay, 4 lists brought together using the 0 axis, and that's what you end up getting. Then the next one, I'm going to go in and run it by the axis equals to 1. Let's do that one. So over to 1 and here, and then we're concatenating a totally different way. So now you can see it. It's bringing those two together, 1, 2, 3, 7, 8, 9, and then 4, 5, 6, 9, 10, 11. So that's another way of concatenating things on a different level. And then I think that's very similar to using VStack and HStack because those methods are shortcuts for the vertical and horizontal concatenations. So I just showed the example of the one again, which produces the data you'll see here. Now I should probably take off my cache servers and cached memories, and every time I do that I want to update. Let's just slide through and see what that one does. That should produce our first series again, 1, 2, 3, 4, 5, 6, right? And then over here, as I do the horizontal stack, it should be the same. Let's do that, and we should get the same data again, 1, 2, 3, 7, 8, 9, and 4, 5, 6, 8, 9, 10. So that's it. And I think there's even more of a shortcut when it comes to. And then I've got one in here that's about row stack. And where did I put that one? Oh, it gets more complex. Row stack I popped in here. And this is a, to start, a slowly creep into more and more column stack method. So row stack method, a column stack method, which is a little different than the row stack. It takes a little more details than this one. This one works pretty much the same. Row stack will do almost exactly the same as the VStack. So let's get that one up and running, right? And slide through here. That should give us the same numbers as before. And then this one's a little different. That's the H stack. There's the column stack. So the column stack comes in, and you have to do a little bit, something a little different here, where you had the tally column stack as AR and A2, array 1 and array 2. So there's the H stack. And the column stack figures out what it needs to do. And what is the output? No, it looks pretty similar, and our column stack should work just fine here. And I didn't get that up and running first. Column stack, boom, boom, and there we go. And you get the column stack, which is the same as the horizontal stack. This one's the same as the vertical stack. And then I have this D-stack method, which came in. I was like, what is a D-stack? And D-stack, I don't even know if I wrote any notes on it. Coming through again, this is going to be interesting because you're getting into multiple dimensions with this one. You can see the call here, and keeping track of it, you've got to get to a second level of elements. Let's go here, hit this one, start this one over, and there you go. You get that call. Everyone stays separate. So I get 1 and 5. I get 2. The next one would be 2 and 6, and then 3 and 7. And then the next one would be 4 and 8 as it goes through. And I probably could have more outputs as I go because I'm only got 4 outputs coming here, but that's enough to get us started on the D stack. So choosing what exactly that is. Oh my gosh, where was the D stack hard coded? D stacks arrays along the 3rd axis. So you just keep adding to more and more axes, because you're going to want to make multi-dimensional arrays. And then splitting, how do we split things? How to divide things up? And things get a little more complicated here. You can see that I start getting in some really juicy information. But I'm going to take that over as the second part of this video. And we're going to start with that in a minute. I'm just going to reset myself for splitting. And we're going to go in and I'm going to get these all running first. And then we're going to come down and have the script going. So thanks very much for watching. I'll make another video in a minute.